Hi boys and girls, today I'm going to show you Test Prep Day 5, Numbers and Operations in Base 10. Let's begin. Which two statements about the values of 34 thousandths and 3 and 4 tenths are true? So let's look. A, B, C, and D, it says it's 1/10 of, 100 times more, 100 times more, and 100th of. So let's look at these two numbers lined up and compare them. We have 34 hundredths and 3 and 4 tenths. So, the first one says that this number is 1/10 of this. Well, is this 1/10 of this? Well, if this is 1/10 of this, it would be this divided by 10, or 1/10 of, which would, the decimal would be right there. So is this 1/10 of this? No, because there's a decimal and then a 0. So it can't be A. B says 34 hundredths is 100 times more than that. Is this more than that? No, that doesn't make any sense because it's not more, it's less than that. 3 and 4 hundredths, or 3 and 4 tenths, or 3 and 40 hundredths is 100 times more than that. So if we took this and multiplied it by 100, would it be equal to this? Well, let's see. Here's my decimal times 10 times 100. 3.4. Is this one 3.4? Yes, so that means this is 100 times greater than this. And let's check D. So D says that this number is 1/100th of this. So 1/100th of this. So that would be this divided by 100. So if we divided this by 10 and divided it by 100, the decimal would go here, and we'd have to put a 0 in the open spot. So it would look like that, which is exactly what our other number looks like. So both C and D are correct because it says which two statements about the values of those are true. We have to solve the following problems without showing work. So I'm going to use my arrow here to help show the work. And when something says to solve without showing work, are they going to penalize you for showing work? No. So if you have to show work, absolutely do it. If we're taking 3,632 and 1/10 and dividing it by 10, all we need to do is move this decimal. They just don't want you to set this problem up. 3,632 and 1/10 divided by 10. They don't want you to do that, okay? Because we know all we have to do is move the decimal. So we're going to take our decimal and we're going to move it back 1 because we're dividing, and division is going to make a smaller number. So we're going to move our decimal back 1 place, and we're going to put the decimal between the 3 and the 2. So the answer is 363.21. So 363 and 21 hundredths. B, we're dividing by 100. Oh my goodness, where's my decimal in 455? Let's think about that. There's an imaginary decimal after every whole number. My students know that I do a little dance with that. So we know that at the end of this number is the decimal. There's an imaginary decimal right here after this last 5. If I'm going to divide it by 100, I've got to move my decimal 2 places back, because divide by 10 moves it there. Divide by 100 moves it there. The answer is 4 and 55 hundredths, or 4 and then your decimal 5. C says 32 and 1/10 times 10. So because we're multiplying, we want our number to get larger, which means we're going to move it to the right. We're going to move our decimal to the right. We're going to move it 1 time because we're multiplying by 10. So we move our decimal from here 1 place, and our answer becomes 321 with the decimal at the end of the number. And our last one here says 345 times 1,000. So again, where's my decimal? I have an imaginary decimal after every whole number, so it's right here at the end after this 5. If I want to multiply by 1,000, I'm going to write this one down to show you as I move it, since there's not a lot of space there. Here's my decimal. I'm going to multiply by 10, multiply by 100, multiply by 1,000. My decimal ends up right here. In these open spaces, I have to make sure I put zeros. They're holding the place of nothing that's there. So my answer is 345,000. We have to solve these problems. So first, we are subtracting. The rule when adding and subtracting decimals is to line up our decimals. So that's what we need to make sure we're doing, is lining up our decimal. Does anybody know why we line up our decimal? Let's hope you do, because you have to line up the decimal to help line up the place value, okay, the place that it's in. You want to line up the hundreds place and the tenths place and the ones place and the tens place. So you want to line up your decimal. Oftentimes when I have nothing in that space, I'm going to put a 0 so that I know that there's nothing in that place. So 9 minus 0 is 9. 4 minus 7 I can't do, so I have to borrow from the 1, make the 1 a 0, make the 4 14. 14 minus, take away 7 is 7. My decimal comes straight down into my answer. 0 minus 0 is 0. 9 minus 0 is 9. So the answer to 91 and 49 hundredths minus 7 tenths is 90 and 79 hundredths. Now let's add. Same rule applies. We have to line up our decimals. So 62 and 573 thousandths plus 4 and 328 thousandths. All we have to do is, after we line them up, is add as normal. 8 plus 3 is 11. 7 plus 2 is 9, plus 1 is 10. 5 plus 3 is 8, plus 1 is 9. Decimal comes straight down into my sum. 4 plus 2 is 6, and 6 plus 0 is 6. So 62 and 573 thousandths plus 4 and 328 thousandths is 66 and 901 thousandths. C wants us to multiply. This is a little different. Do we have to line up our decimals when we multiply? No, because what we do is a little different than when adding and subtracting. We have to make 8 and 6 tenths a whole number. So how can we make this a whole number? We're going to multiply this number by 10 to move this decimal out of the way. So I'm going to move this decimal out of the way by multiplying by 10. Okay, and I'm going to save this because I'm going to need to use that in my product. So 7 times 6 is 42. 8 times 7 is 56. 56 plus 4 is 60. Now I've got to look back and remember that I multiplied this number times 10 to make it a whole number, and I need to do the inverse, or the opposite of multiplication, which is division in my product. So I need to divide it by the same thing that I multiplied by, which was 10. So I'm going to divide by 10, and I'm going to move that decimal back in here. So the answer to 8 and 6 tenths times 7 is 60 and 2 tenths. And a way to check that this is reasonable, we can round. 8 and 6 tenths is close to 9, and 7 is close to 7, and 9 times 7 is 63. Is this close to 63? Yeah. So I know that my answer is reasonable. Which is equivalent to multiplying a number by 10 to the third? Well, I know that 10 to the third looks like this. So 10 to the third is equal to 1,000. Okay, and I know that 10 to the third is 10 times 10 times 10, which is 1,000, because the 3 tells us how many times we see 10. We see 10 3 times, so 10 times 10 times 10. So is that A, adding 10 3 times? No, it's got nothing to do with addition. Is it adding 3 10 times? No. Is it multiplying by 10 3 times? Yes. Or is it multiplying by 3 10 times? No. So we know if we looked at what we already knew about that number, we could figure out that 3 don't make any sense, and C is the best answer. This says to circle all the numbers that round to 4 and 3 tenths when rounded to the nearest tenth. So I'm going to take each number, 4 and 25 hundredths. We want to round to the nearest tenths place. So we're going to locate the tenths place. We're going to look to the right of that place at the 5. That 5 tells me that we're going to round up. So we're going to round the 2 to a 3. And the 5 becomes a 0, and everything before it stays the same. So does the first one round to 4 and 3 tenths? Yes, it does. We also could use a vertical number line. We have 4 and 24 hundredths, so we'd go 4 and 2 tenths or 4 and 3 tenths. Halfway between 4 and 2 tenths and 4 and 3 tenths is 4 and 25 hundredths. Where does 4 and 24 hundredths fall on this line? It falls right about here, which means it would round down to 4 and 2/10. So would that round to 4 and 3/10? Nope. How about 4 and 21 hundredths? We could either look here and look to the right. We know the 1 does not make it round up, so it's going to stay at 4 and 2/10. Or we could look at our vertical number line. It'll be the same vertical number line. 4 and 21 hundredths falls right about here, which means it rounds down to 4 and 2/10. So it does not round to 4 and 3/10. We have 4 and 35 hundredths. We are looking at the tenths place. We look to the right at the 5. The 5 tells us we're rounding up, so the 3 becomes a 4. Everything before it stays the same. Everything after it changes to a 0. 4 and 4/10 is not 4 and 3/10, so that's not correct. Then we've got 4 and 34 hundredths. Underline the 3, look to the right. The 4 tells me we're not going to round up, so the 3 stays the same. Everything before it stays the same. Everything after it changes to a 0. That does round to 4 and 3/10. And the last one I'll show you on another vertical number line. We've got 4 and 31 hundredths. 4 and 3/10 is our bottom number. 4 and 4/10 is 1/10 more. Halfway between 4 and 3/10 and 4 and 4/10 is 4 and 3/10 5 hundredths. This number is 4 and 3/10 1/100th. So we're looking right about here, which means it would round down to 4 and 3/10, which is exactly what we wanted to know. So the first, the last, and the second to last will all round to 4 and 3/10. A full tank of gasoline costs $41.40. If the car has a 12-gallon tank, approximately how much does a gallon of gasoline cost? So let's look at this problem. A tank of gasoline costs this much, and the car has a 12-gallon tank. That means it holds 12 gallons. They want to know how much does 1 gallon or a gallon cost. So we want to know how much each gallon costs. If 12 gallons cost this much, how can we find out how much each gallon costs? We need to divide. So we're going to take $41.40. We're going to divide it by 12. When dividing decimals, we just need to make sure there are no decimals in our divisor. And because there's not, we don't have to worry about that. All we have to do is bring this decimal straight up into our quotient. I'm going to try 12 times 3 is 36. That's pretty close. And then I'm going to subtract. 11 minus 6 is 5. Bring down the 4. 12 times 5 is 60, I know. So 12 times 4 is 48. That's pretty close. Then I subtract. I get 6 left over. Bring down the 0. I know that 12 times 5 is 60, something I always remember. So each gallon of gas will cost $3.45. So let's look at our possible answers. We have $3.48, nope. $2.88, nope. $3.54, nope. $3.45, there it is. So again, you see that I did my work and then I checked the answers. Our last problem today says Helen babysits 2 children, a 1-year-old and a 6-year-old. She gets paid $5.36 an hour for the 1-year-old and $3.86 an hour for the 6-year-old. If she babysits them both for 6 hours on Saturday, how much money did she make that day? So she's got 2 children, a 1 and a 6-year-old. She gets paid $5.36 for the 1-year-old and $3.86 for the 6-year-old. She babysits them both for 6 hours. So we get $5.36 for 6 hours, right? And she gets $3.86 for 6 hours. So we're going to multiply 536 times 6 to find out how much she gets paid for the 1-year-old. We're going to multiply 386 times 6 to find out how much she gets paid for the 6-year-old. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. 6 times 5 is 30, plus 2 is 32. And we had to multiply by 100 to make this a whole number, which means we have to divide by 100. So she gets paid $32.16 to babysit the 1-year-old And let's find out how much for the 6-year-old. 6 times 6 is 36. 6 times 8 is 48. Plus 3 is 51. 6 times 3 is 18. 18 plus 5 is 23. Again, we have to multiply by 100 to make that a whole number, which means we have to divide by 100 to get our decimal back into our product. So she gets $23.16 for the 6-year-old and $32.16 for the 1-year-old. They want to know how much money did she make that day. So how much money total? What do you think we should do with these two numbers? Yes, we should add them. So $32.16 plus $23.16. 6 and 6 is 12. 1 plus 1 plus 1 is 3. Our decimal comes straight down. Remember when we added decimals, we've lined up our decimals. 3 plus 2 is 5. 3 plus 2 is 5. So on Saturday, she made $55.32 babysitting.